Hello, everyone. I'm Cabeleira, and first of all, I would like to thank the event's scientific committee for accepting the communication, allowing to discuss a subject that has been at the very center of my pedagogical practice and research. Even more, due to the ongoing reformulation of the geometry course in the integrated master degree in architecture at the School of Architecture, Art and Design of the University of Minho, a moment in which the syllabus, referencing framework, teaching learning strategies, evaluation model, ELATIC thematic guidelines, and Summon-Hop instrumental resources are being reequated. In fact, and looking at our school, architecture training has never followed the mere prescription of formal and mechanical tasks. In fact, focus falls upon research methodologies engaging abstract thinking, theoretical background, technological awareness, and graphic speculation, all condensed on studio design. Nevertheless, and especially regarding geometry, this science is taken as an essential knowledge for architectural training and practice, implying simultaneous actions such as approach to projective systems, characterize the geometric lexicon, inquire and interpret space, solve form-space problems, propose hypotheses. Actions that altogether inform, support, and substantiate architectural design practice and thinking. Concerning the role of geometry within architectural training, we cannot fail to summon the words of Gaspard Monge in the opening of his Géométrie descriptive about the discipline's objectives. The first, to provide methods for representation on drawing sheet that has only two dimensions, namely length and breadth, all bodies in nature that have three of them, length, breadth, and depth, since that these bodies can be rigorously defined. Following also his words, the second objective is to give ways to recognize, after an exact description, the shapes of bodies and to deduce from them all the truth that results from both their shape and form, their respective positions. Monge's words envisioned a clear complementarity between representing and recognizing, to which are invoked multiple resources since descriptive and analytic thought, as well as simultaneity among intuitive, inductive, and deductive reasoning. As such, it is essential a strong cognitive structure condensing the wide range of implied contents and procedures. Moreover, if abstract visualization, graphic materialization, drawing techniques, geometric lexicon, and form generative procedures may be approached as autonomous topics, it is under geometrical science and through drawing that they are gathering, organizing a strong and interconnected taxonomy. However, learning is often defined under the dichotomy between practical knowledge on one hand and theoretical knowledge on the other. Intending to escape such dichotomy, the application of a project-based learning methodology to geometry avoids the misperception between learning and responding to a specific task that, in this particular case, reduces geometry to mechanical procedures and technical drawing. Searching for an effective interconnection among theoretical and practical knowledge, the project-based learning methodology fosters experimentation and research, demanding an active engagement with the process. As such, problems are placed under general premises, invoking theoretical contents and instruments, giving each student the chance to explore own motivations. In order to illustrate the application of such methodology, we can point out two work proposals recently developed. The proposal, tessellations, surface modeling, applying origami and kirigami principles, invites the students to transform a flat surface into an elaborated complex structure covering an area of 100 square meters. The essayed solution requires, in addition to the developed model, the mathematical and geometric interpretation of its shape, cross-referencing theoretical and practical contents, poured into graphic projections. Through this exercise, each student develops a personal solution to the detriment of responding to an assignment strictly concerned with projective mechanics and graphical conventions. Another example was the proposal, Our Home in Network, Private and Relational Space. Developed during the 2020 lockdown, work was organized since groups of 3 students that, although at a distance, surveyed their homes and interconnected spaces from each one's house among them. Such articulation should result from unusual interconnecting elements, such as a fireplace, a drawer, or a cupboard, questioning not only the geometrical properties of the inhabited space, but also possibilities of spatial thinking in its formal combination and relational potentials. Being materialized graphically, the assignment main output was not a final product, a so-called project, but intermediate drawing stages essential to foster critical discourse and design research. From the above exemplified, geometry emerges reinforced as a basic science to the thought and praxis of architecture, manifesting itself essentially through drawing and incorporating, as Frescari points out, a cosmopoetic dimension. Quoting the author, architects execute their common and differentiated ways of making drawings through a sequence of operations based on composition and decomposition, weighting, ordering, exclusion and supplementation and deformation. By tracing, architects perform an act of creation of the world, a cosmographic expression that is also the root of the future cosmopoiesis. End of quote. Under such creative and envisioning power, the geometrical, cognitive, and instrumental resources release themselves from being reduced to a prosaic device, evoking, in the words of Pérez Gómez, quoting him, temporality and limits, defining the space between light and dark, between the principle and the beyond, it illuminates the space of culture of our individual and collective existence. End of quote. Following this line of thought, the syllabus under consideration is based upon 2 fundamental domains: relational geometries, which due to their synthetic nature are aimed at understanding and conception of form and space, along with representative geometries, whose analytical purpose provide accurate resources for the representation and questioning of the material and immaterial world, a duplicity that recalls the objectives stated by Gaspar Monge, intertwine and are materialized under a set of 4 functionalities individualized by Millara: free-ending drawing, which supports observation, inquiry, and critique; geometrical drawing, materialization, verification, and communication of the established thought; modeling, for verification and speculation; and finally, reverse modeling, amplifying paths for the research process. Taking the words of Frescari, the graphic reasoning in architecture teaches the look to go beyond the visible image to an infinity where something new from the invisible is found. In the same order, Christensen expresses that to say that architecture becomes thinkable through representation is another way of saying that representation provides a framework for thinking upon which or through which concepts and architectural ideas are perceived, questioned, and organized. Looking retrospectively, previous applied methodology evidence an excessive domain over projective geometry, leaving little space for relational geometries, a situation that prevents greater opportunities of trial and error in the exploration of geometric architectural thinking. In this sense, it is necessary to reinforce the prevalence of both physical and graphic models, applying simultaneously all of Migliari's functionalities, foster problems of interpretation, characterization, conception, and modeling. It is under such premises that the course's contents and thematic organization are reoriented. Systematized in 2 semesters, components taught in the first semester will mostly deal with geometrical rudiments, debating the characterization of 2-dimensional and 3-dimensional entities, as well as operative procedures concerning double orthogonal projection, axonometry, and linear perspective. The second semester will deepen the characterization of surfaces and complex structures, namely through the definition of different types of surfaces, along with rudiments of cartography and solar geometry. Such differentiation could be named after polyhedral characterization and transformation, as for the first semester, and of characterization and operationalization of surfaces for the second semester. Under this grid, it is important to highlight that the redefinition of contexts and thematic organization acts simultaneously since 3 different sources, being the third an aggregating element of the other 2. First, characterization of the geometric lexicon, namely figure, curves, polyhedrons, and surface, along with their generative operations. Second, exploration of graphical models, namely in its projective background, cross-referencing different systems and their spatial mechanics and reasoning. Third, thematic election, guiding work proposals, such as space, form, modeling potential, scale of the inhabited and represented space, and 3, the experience of space. In this pursuit, some essays have been developed, largely catalyzed under the actions of composing, manipulating, interpreting, and communicating. Exercise sequences aiming for a progressive consolidation of developed structures to the detriment of shorter assignments, often oriented to a specific projective procedure. This is the case of an exercise which advocated the transformation of regular polyhedral, comprising its projections and surface flattening, along with other exercise dealing with the binomial shape and space, mass and void. Finally, other exercises dealt with the deconstruction of the image of space, finding ways to analyze the space inhabited by the body and the gaze. The proposal, departing from Eduardo Chillida, allows to dive into the field of geometry and abstract spatial reasoning. The exercise considers a set of engravings by the Basque artist, from which a corollary of interpretative and propositional actions is developed. In a first moment, and chasing for the geometric code interpretation, the aim is to analyze the geometric structure of the bidimensional image, being possible to apply different methodological approaches for data management. The goal is to achieve a geometrical matrix capable of explain the structure and reproduce it. From the achieved flat matrix is requested the generation of a three-dimensional composition, exploring two distinct aspects, its volumetric characterization and its internal spatiality according to pre-established premises. Still, in a first stage, this composition is fixed in a double orthogonal projection, but in a second stage is materialized by axonometry, allowing the simulacrum of its volumes as well as the internal voids and respective articulations. Thus, the idea of representing the internal space in section is cross-referenced with another one managed according to an assumption of transparency of the overall volume, giving rise to the inversion of positive-negative. The house of cards work sequence departs from the structure designed by Ray and Charles Eames to explore the potential of modular combinatorial. The modular structure serves as an exploratory trial where through application of linear perspective, it is possible to verify its metric properties, spatial qualities, infinite combinatorial, and tectonic expression. However, in a second phase, each student proposes variation of the module, where, although following a coincident logic, new formal and spatial qualities arise. At this moment, the propositional capacity of each student is at stake, being challenged to explore complexity both in terms of form and application of theoretical and practical contents. An identical challenge arises from the transformation of a plane grid into a spatial network. According to the application of altimetric volumes to node points, subordinated to mathematical progressions, as well as their distribution in space. The new surface is thus consequent to the distortion of distances that, when later combined with rule and topographic surface, allows to explore different methodological approaches to its interpretation and confirmation. Pursuing the logic of reverse modeling, perspectival restitution regards the application of specific projective knowledge in the management and confirmation of the image of space. In this case, and departing from the painting of Saint Jerome in his studio by Hendrik van Steenwyk, the structure of the image and of the portrayed space is analyzed, proceeding subsequently to its deconstruction in a process that serves both architectural survey procedures as well as the control of the architectural image generated in more complex supports such as digital rendering. Once again, in the incessant search and inquiry that characterizes architectural research, geometry provides cultural, conceptual, and instrumental resources, as well as methodological competences that converge to the wide range of problems that arise within the scope of disciplinary action. As Enrique Miralles pointed out, the best thing about drawing is its intermediate states that allows one to see beyond what is expected or pursued. However, we can only glimpse such possibilities if instructed with the theoretical and practical resources that consent us to pass beyond the immediately visible. We are thus led to a procedural dimension, either abstract, the idea, and material, graphic, from which Christensen asserts, through numerous procedures and acts of architectural representation, architects make and test statements, define priorities, and later question them, generate alternatives and options, concretize and abstract concepts. In short, they produce architectural knowledge. The explored course readjustment, which basically corresponds to the emergence of distinct and simultaneous functionalities, as well as a prevalence of geometrical reasoning over a mere mechanical approach, compete with the fully application of a project-based learning methodology, a positioning that embodies Wall's statement expressed in parallels. Working with doubt can produce an intrinsic affirmation of human choice that gives presence to an idea. Thank you very much for your attention.